Hello everyone! Our presentation today is on the topic radio wave-based imaging, where we will explore how radio waves are used in technologies like GPR, MRI, and millimeter wave scanners. We are from Group AS1204M and our team members are Najma, Salwa, Aisha, Ayuni, and Afika. So each of us will cover different parts of the topic to help explain how radio wave-based imaging works in science, medicine, and public safety.
This is all the content that we will discuss in this video. The first one, we go through about introduction and principle of radio wave imaging. Next is GPR, MRI, millimeter wave scanner, comparison, challenges, and future use. And the last one is our references.
Before we explore how radio waves are used in imaging, let's understand what they actually are. Radio waves are a type of electromagnetic wave, just like visible light, X-rays, or microwaves. What makes radio waves different is their long wavelength and low frequency, which means they carry less energy compared to X-rays or gamma rays. But that is also what makes them safe and useful for many technologies. They also can travel through air, walls, and even the human body, which is why they are so useful in non-invasive imaging systems. So, how does radio wave-based imaging actually works? The process is quite simple. A device sends out radio waves into an object or area. As the waves travel, some of them reflect back, some pass through, and others might be absorbed by different materials. The system then detects the returning signal, and software uses that information to create a detailed image. Kind of like how a bat uses echolocation to see in the dark, but here we are using the radio energy instead of sound. This same basic principle is used in technologies like GPR, MRI, and millimeter wave scanners. Just a quick look back, in 1865, scientist James Clerk Maxwell predicted the existence of electromagnetic wave, including radio wave, through his famous equations. Then, in the 1880s, Heinrich Hertz proved their existence by generating and detecting radio waves in a lab. Their discoveries paved the way for all kinds of wireless technology, from radios and radar to the advanced imaging techniques that we will explore in the rest of this presentation.
Second, what is GPR? GPR, ground penetrating radar, is a non-invasive geophysical method that uses radio wave to image the subsurface. It used to detect objects, changes in material, voids and cracks beneath surface like soil, rock, concrete, or asphalt. Next, how GPR works? A GPR system consists of two antennas. First, transmitting antenna emits high-frequency radio wave into the ground. Second, receiving antenna records the reflected signal from the subsurface structures. Then, when the emitted wave hits an object or a material boundary with different electrical properties, some of the wave energy is reflected back to the surface and captured by the receiver. Third, the time it takes for the radar signal to return is used to estimate the depth and shape of the object or a structure. Last but not least, here are the state of frequency. Let's go to the next slide. As you can see, GPR it has many real-world uses across different fields. Let me walk you through some key applications. First, construction. In construction, GPR is used to locate rebar, conduits, and voids inside wall or concrete slab. This is especially important before drilling or cutting to avoid damaging important structure or causing safety hazard. Second, archaeology. In archaeology, GPR help researchers detect grave, ancient wall, or buried artifacts without needing to dig everything up. This means they can explore historical sites while preserving them. Third, in military application, GPR plays a critical role in detecting underground threats such as landmines, enemy tunnels, or hidden bunkers. It provides valuable information while keeping personnel at safe distance. Next, geology. In geology, GPR is used to map bedrock layers, detect fractures, or locate groundwater. It helps geologists understand the structure of the earth beneath our feet, especially in areas where drilling might be difficult or expensive. Finally, in forensic science, TPR helps locate clandestine graves or hidden evidence. It's often used by police or investigators in cold cases, offering a non-destructive way to explore suspicious sites. So, as you can see, TPR is much more than a scanning tool. It is a vital technology used in construction science, security, and even solving crime. Its ability to see underground without digging makes it safe, fast, and effective solution in many industries.
Have you ever wondered how doctors can actually see inside our bodies without cutting us open? That is where MRIs come in. So, subtopic 1.3 is all about magnetic resonance imaging. Alright, so here is a video showing how an MRI or magnetic resonance imaging works in real life. You can see the patient here going into the machine. It looks like this big tunnel or a giant donut, right? But don't worry, it's not painful or anything. Basically, an MRI is a medical imaging technique that lets doctors see inside your body in really high detail, especially your soft tissues like your brain, muscle, or internal organ. What's cool is, unlike X-ray or CT scan, MRI doesn't use any radiation at all. Instead, it uses a powerful magnetic field and radio wave to create those detailed images. That's why MRIs are super helpful and safer when scanning sensitive part of the body. So yeah, if you ever need one, now you know. It's just magnet and radio wave doing all the work, no scary radiation involved. Okay, so here what else MRI can actually show us. The first one showing the brain and the spinal cord. MRI are really good for scanning the brain because they can capture super clear images of soft tissues, so doctor can check for things like brain injuries, tumors, or even spinal cord problems. Second picture, this one all about the muscle, ligaments, and tendons. MRI can help doctors see if there are tears, injury, or inflammation in this area way better than regular X-ray. And finally, we have picture of kidneys. So even internal organs like the kidneys can be scanned with an MRI to check for things like cysts, infection, or other abnormalities. So yeah, MRI is not just for bone or one part of the body. It's great for detailed, safe scanning of soft tissue all over. Alright, to wrap up this part about MRI, let's quickly talk about why MRI is actually better than X-ray or CT scan, especially for certain cases. First of all, MRI doesn't use harmful radiation, so it much safer, especially for people who need multiple scans. Plus, it gives really high quality image of soft tissue, like I just mentioned just now. That's why doctors use it to help diagnose things like brain tumors, joint injuries, or spine problems. And for your information, it's also super safe and non-invasive, which means they don't have to cut or poke anything. The patient just lies down in the machine, it's painless, and if needed, the scan can be done multiple times with no harmful side effect. So overall, MRI is a safer, more detailed option, especially when doctor needs a clear look at soft tissue inside the body.
Okay, so now let's talk about the millimeter wave scanner, the only you usually see at airport security. This scanner is a full body imaging system that uses non-ionizing electromagnetic wave. That means it's not harmful like X-ray. The wave used are quite long, between 1 to 10 mm of wavelength, and they can detect hidden objects under clothes whenever it's metal or non-metallic. But don't worry, it doesn't show your actual body. Now, if you look at the picture here, the scanner creates a kind of ghostly image. But don't worry, the image is privacy friendly. And another plus point, it's safe for humans because it doesn't use ionizing radiation, which means No health risk even if you are scanned, often including for children or pregnant women. Alright, so how exactly a millimeter wave scanner used in airport and security? Well, you will usually find them at airport checkpoint. You know that the moment when you step into the booth, raise your arm and stand still for a second. Yep, that's the one. This scanner do a full body scan to detect hidden object under clothes. What's special is that they are not just looking for a metal, they can also detect non-metallic items like plastic bottle, ceramic weapon, even power substance. This scanner then generate a 3D image or a generic human outline like the ones we show earlier and highlight any area that looks suspicious, usually with a box. Let me show you a short video so you can see exactly how it works in real life. Now, let's talk about the two really important things, privacy and safety. First is privacy. One of the biggest concerns people have is, will the scanner show my actual body? The answer is no. The scanner displays a basic mannequin-like figure, not your real body image. There are no photos taken, no name shown, and absolutely nothing is saved or stored. It's all the process is real-time and then delete. So, your privacy stays full protected. Now is safety. Millimeter wave scanner use non-ionizing radio wave, which means they don't carry the kind of energy that can damage your cell or DNA. So, they are considered very safe, even for people who are more sensitive like children or pregnant women. In fact, these scanners are approved by Health and Security, including the US TSA. So, overall, it's safe, smart, and privacy-respecting technology.
PR, ground penetrating radar, MRI, magnetic resonance imaging, and millimeter wave scanner. For the radio wave use, GPR send radio wave into the ground to detect buried object or layers. For MRI, radio wave use radio frequency signal and magnetic field. There are 4 benefits in this chapter. First, safe, non-ionizing radio wave. Second, non-invasive, provides detailed imaging. And the last one is no direct contact needed. For the challenge, signal interference from metals, electronic noise, and environment. High cost, especially MRI machine. And last one is resolution limitation, especially in GPR and scanner. Future innovation, autonomous vehicle, GPR for route structure, mapping, radar-based navigation. The second one is wearable sensors, MRI technology, miniaturized for health tracking. And last one is smart building, millimeters wave for structural monitoring and internal mapping.
That's all from us. Thank you for watching.